Let us discuss semiconductor. The most common examples of the semiconductors are silicon and germanium. Let us consider the atoms of a semiconducting material, silicon. Silicon has 14 electrons, orbiting in 3 orbits. And they are distributed as 2, 8, and 4. Means 2 electrons are in innermost orbits, 8 electrons are in next 2 innermost orbits, and 4 are in outermost orbit. Silicon atoms have 4 valence electrons, and 4 holes in their outermost orbits. The closer an electron is to the nucleus, the stronger is the binding force between the electrons and the protons in the nucleus. Electrons in the outermost orbit are comparatively loosely bound with the nucleus. This means a small amount of energy will be required to take out an electron from the outermost orbit. When an electron leaves its orbit, it becomes a free electron. A semiconductor atom having 4 valence electrons. And 4 vacancies for electrons. These 4 vacancies require 4 more electrons, so as to make the outermost orbit completely filled with total 8 electrons. The atoms in a crystal are arranged so closely that each valence electron orbits in valence shells of 2 adjacent atoms. Each valence shell electron fills the hole of the neighboring atom, as shown. In the figure, atoms of silicon material have been shown. For ease of understanding, only the outermost orbits of atoms have been shown. Sharing of electrons of the neighboring atoms to satisfy the need to have 8 electrons on the valence shell in an atom is called covalent bonding. Because of covalent bonding, that is, bonding through sharing of electrons, it is seen that the valence shells of all the electrons are full, that is, all of them have 8 electrons in their outermost orbit. At absolute zero temperature there will be no free electrons in the crystal. However, although the electrons are bound to their atoms due to covalent bonding, a rise in temperature breaks some of the covalent bonding and makes some electrons free. When the temperature of the crystal is raised, external energy in the form of heat gets applied to the semiconductor material. This heat energy enables the valence electrons to acquire sufficient energy to break away from the atoms and become free electrons. When an electron leaves to become free, it leaves a vacant space called a hole. For every free electron, there will be a corresponding hole produced, which is called an electron-hole pair. A large number of such electron-hole pairs are formed due to rise in temperature of the semiconductor. When electrons become free, they get attracted and fall into a hole created by another electron. This merging of free electrons and holes is called recombination. The time of creation of a free electron and its falling into a hole is very quick, and the time taken is of the order of nanoseconds. Thus, pure silicon or germanium is not of much use in electronics except for the manufacturing of heat or light-sensitive resistance. Hope you got a basic idea of semiconductor. Thank you.